Welcome to this online revision session for AQA FP4, in which we will be doing the June 2011 question 1 on determinants and inverses. Well, as you can see in this particular question, we've got to find the determinant of A and B, both of which are 3 by 3 matrices. And then in the second part, without finding AB, we have to find the values of P for which AB is singular. You remember, if AB is singular, if and only if its determinant is equal to 0. So we need to know how to find the determinant of AB without actually finding AB. Well, let's get on with the first part of this question. In the first part, we need to find the determinant of A. And really it's just a question of deciding which row or column to use in expanding this determinant. And since P is in the top row, it would seem to make sense to use the top row as the expansion. So we start with 1 times the determinant of 2, 1 minus 1 times negative 1, which is 3. And then we've got P, and we have to remember in our grid that this is plus, minus, plus. So this is going to be P times the determinant of negative 3 and 1 minus 2 times 1, which gives us negative 3, negative 2, negative 5. But remembering that negative sign, that becomes plus 5P. And then finally with the 4, we are going to have the determinant of negative 3 and negative 1 and 2 and 2. So that becomes 3 minus 4, which gives us a negative 3 minus 4, yeah, negative 1 with that 4, so that's going to become a minus 4. And so overall we've got 5p minus 1 for that first determinant. Similarly now, if we do the determinant of B, again it's a case of deciding which row or column to use. And in this particular case, since P is occurring twice, it would seem to make more sense to use the bottom row to expand. So if we take 2 times whatever we've got with the 1, the negative 1, and the 5 and the P, so that's going to give us twice negative 1 and negative 5p, so that becomes negative 2 and negative 10p. Remembering that's plus, that's minus, and that's plus again in the grid. Then we got 0, so there's nothing to worry about there because it's just 0 times a 2 by 2 determinant. And then finally we've got 1 times the determinant of P and 1 and 9, which is just going to give us plus P squared minus 9. So overall our determinant is P squared minus 10p minus 11. Well, there are just 3 marks there, so you'll get 1 mark for obtaining the correct value for the determinant of A. And similarly for determinant of B, which is a bit more complex, they're going to give you a method mark for working through this one, as well as an accuracy mark for obtaining the P squared minus 10p minus 11. So that's part A dealt with. Now in part B, if you remember, we're being asked to show or find the values of P for which the matrix AB is singular. Remember, for it to be singular, its determinant has to be 0. So how do we find the determinant of AB without actually finding AB? Well, the key thing we need to remember is the determinant of AB is the same as the determinant of A multiplied by the determinant of B. And for it to be singular, this must equal 0. So that is going to imply that 5p minus 1 multiplied by the p squared minus the 10p minus 11 must equal 0. And of course that in turn implies if we complete the factorisation, we're going to get 5p minus 1 multiplied by, well, to get p squared we're going to need a p and another p, and then to get your negative 11 it's either negative 11 and 1 or 11 and negative 1, and since this is negative 10p it must be negative 11 and plus 1, and that equals 0. And so our possible values of p are p from this first bracket must be 1/5. In the second bracket it could be 11, and from the third bracket it could be negative 1. Okay, so for stating determinant of AB equals determinant of A times determinant of B, you'll get a mark. For then using an appropriate method in order to find these three values of P, you'll get 1 mark. And then an accuracy answer for obtaining those three correct values, you will get 1 mark. Well, hopefully that solution you found helpful. For further support for your revision for A-level Further Maths, please go to the Further Maths Support Programme website.